Hey everyone, today we're going to talk about the differences between linear functions and exponential functions. You'll be successful when you can tell the difference between the two looking at the equation, looking at a table, looking at a graph, and then we'll also be successful if you can discuss the differences between the domains and ranges of those two functions. So let's get started. Let's first talk about what the equations look like between a linear function and an exponential function. You may remember that a linear function always takes the form of y equals mx plus b, where m tells you the slope of the line, or in other words, the rate of change. And b is your y-intercept, if we're talking conceptually, and if we're talking about a real-world problem, it's your initial value. Exponential functions, on the other hand, take the form of y equals a times b to the x power. So here your variable is down here with the m. In this one, your variable is the exponent. So that's not a typo. That is an exponent. A represents your y-intercept in these problems, or your initial value, and b is your factor of change, similar to a rate of change. Excuse me. So let's dive into what these problems look like. The first problem we're going to look at is y equals 3x plus 2. And feel free to plug these into your calculator or into Desmos. And let's look at the table. I'm going to go ahead and start this one so we get a couple of negative values, a 0, and a couple of positive values. So we see that negative 2 is equal to negative 4. Negative 1 is negative 1. 0 is 2, and 1 is 5, and 2 is 8. If you were going to do this without a calculator, all you would do is plug in negative 2 for x. So you would do 3 times negative 2 plus 2, 3 times negative 1 plus 2, 3 times 0 plus 2, 3 times 1 plus 2, and 3 times 2 plus 2. So what is the rate of change for these? How do we find that? Well, we just find what do I have to do to negative 4 to get to negative 1? What do I have to do to negative 1 to get to 2? And so on and so forth. And what you should see is that each one of these, you get to the next one by adding 3. Let's compare that to what this exponential function looks like. So again, putting this into your calculator, you get 2 times 3, and this is this little caret button. That's how you tell it to give it the exponent, and the exponent is x. And so this is what it should look like when you put it in your calculator correctly. If you put it in not as an exponent, you're just going to get you're going to get a straight line when you go to graph it, and this should not look like a straight line. So let's go ahead and look at that table and see what that looks like. And for the same values, we get negative 2.22, negative 1.67, 0, 2, 1, 6, 2, 18. And same with over there, you would make this x value the exponent every single time. So 2 times 3 to the negative 1, 2 times 3 to the 0 power, 2 times 3 to the 1, and 2 times 3 squared. All right, so same thing we did over there. We're trying to figure out how we get from one number to the next. So it's easier to see when we're not looking at decimals. So how do I get from 2 to 6? How do I get from 6 to 8? What's common there? If I look at it this way, it's plus 4, it's plus 13. That's not common. What's common is that from here to here, I end up multiplying by 3. And from here to here, I multiply by 3. And if I take 0.22 and multiply it by 3, I get 0.67. If I take 0.67 and I multiply it by 3, I get 2. I'm sorry. So that is, each one of those has a factor of change of times 3, and that's the major difference between a linear function and an exponential function. A linear function goes up by adding 3 every time. This exponential function goes up by multiplying 3 each time. So what we can do now is plot these points. So we have -2. Okay, first of all, let's clearly draw those lines. So -2, -4, and -1, -1, 0, 2, and 2, 8 is going to go off of our grid here, so we're just going to go like that. Oh, but we can do 1, 5. Okay, and if we go to graph this one, really the major thing we want to do is the intercept. So I'm going to draw this one like this. So I have 0, 2, 1, so you can see this one makes a curve, and we can see that if we go to look at the graph of that function. It's not a straight line. It's definitely a curve. All right, and let's talk quickly about the domain. The domain and range for a linear function is always all real numbers, because we go to infinity, negative infinity to infinity in both directions. But the domain for this exponential function, while the domain is all real numbers, you can see the range doesn't go below the x-axis. So this would be all positive real numbers. And this is only when a is greater than or equal to 0, which it is in this case. All right, that's all I have for you today. Next time we come back, we'll do some practice problems. But for today, I just wanted you to take those notes. Have a great spring break, and we'll talk to you soon.